All right, now to measure the melting point, you're going to have to do 2 trials for each one of your compounds. So the way that you go about preparing that is you're going to take the capillary tube and you're going to take the unknown compound. You can get it into the corner of the weighing boat here and just dig around a little bit to get a little bit stuck in the tip of it. It doesn't take a lot of compound. It's okay if you have more, but it only takes a very little bit to do a melting point. Okay? And sometimes when you have it loaded into the tip there, you're not able, even if you shake it sometimes, to get all the compound to fall to the bottom. So there's a little trick we often use around the lab to get it to fall to the bottom. You see I have here a glass rod that has an opening that's wide enough to hold the capillary tube. And I can take the capillary tube, and if I drop it in there, sometimes it takes more than one try. It's also nice to see the tube bouncing, something kind of pleasant about that. Okay. After 1 or 2 trials, you'll see, if you look closely, that the compound will be in the bottom of the capillary tube. Right? So we're going to repeat that 2 times for each compound. We'll have a total of 6 capillary tubes prepared, and keep track of which tube belongs to which compound by putting it in the weighing boat. Okay. Now to start doing the melting point, turn the device on the back here. And after a moment or two, you should hear a kind of humming noise. That's the sound of the refrigeration unit. Whenever this device is not heating up, it's always cooling itself down, getting ready for the next step. Right? So you want to load your samples into these 3 slots here. Keep track of which is which. Do them in their unknown order, 1, 2, and 3, in positions 1, 2, and 3. And then you want to get comfortable with this device. Make sure that you can clearly see the solids in there. And to do that, you have a couple of options. You can move this up and down to whatever position you're comfortable viewing. And you can also change the focus by moving this in or out. Right? If there's anything like a smudge or some dirt in there, you can actually pull the lens off all the way, and you could use a clean paper towel to wipe off either side of the lenses. That's probably not that likely, but if it comes up, you should be able to clearly see the samples. And if I look into here now, I see the bottoms of 3 of these tubes magnified very clearly, and I can see the compounds that are in there. Stop. All right. Now, you're going to have to change the settings on this device throughout this experiment. So the one thing to familiarize yourself with mostly is this mode button. If I press the mode button once, you'll see what's called the plateau temperature. And for the first trials that you guys do, the plateau should be set up at 350. Right? That can be adjusted right now with the up and down arrows, right? It was at 350 already, but if I opened it up and it was 348.7, I would use the up arrow until I get all the way up to 350. Okay? And once you set it at 350 for this trial, you can hit mode once more, and you'll see something displayed which doesn't affect this part of the experiment. We're going to change it later. It's called the slope value. That's how fast a sample gets heated when we go in a slow trial, right? But for now, it doesn't matter what that setting is. It could be 1, it could be 5, it could be 10. So you can just leave it whatever it is. And to exit and save everything you've done, just press mode again. When you do that, you ought to see this screen that was displaying before over and over again, cooling to ambient and so on. Now, in the first week, you're going to measure a rough estimate of the melting point so that in the second week, you can make a very precise determination. The reason that you do a rough estimate is to do a precise determination, you have to heat at a very slow rate. And if you have no idea what the melting point is and you have to go at a slow rate, it'll take a very, very long time to scan through all the possible temperatures. So what we do first is we do a fast heating rate where honestly this temperature that we get might be 10 or even 20 degrees off of the true melting point. But that'll then give us an idea of where to slow down and to heat very slowly in order to accurately determine the melting point. So for this first week, what we want to do is after we've loaded up the 3 samples, just press the start button. And when you press the start button, you'll see the display on the screen changes to say that it's heating. And if you look at the temperatures that are displayed, you'll see they start to rise. And those are relatively fast rising rates. Okay? While it's heating now, you want to be looking in the viewer and watching the samples. Obviously, we're looking to see when the samples melt, but sometimes we also make other observations like ionic compounds with waters of hydration may change in their physical appearance. They may lose cloudiness or change color, or the texture of the crystal may change. We also sometimes see samples decompose rather than melt, and that's usually indicated by something turning yellow or brown. So keep your eye on the samples and watch the temperatures. If you see anything, jot it down. It's part of your data to take note of things like that. The most important thing, of course, though, is to note the temperature at which the sample melts. All right, so you should be watching your samples. The maximum temperature that the device will go up to is 350 degrees in this mode. And if a sample doesn't melt by 350 degrees, we're going to assume that it can't be measured by us today with the equipment that we have. So you should be looking through the viewer and eyeing the samples and looking at the temperature until it gets up to 350 or all the samples melt. Okay. Right. Now, in the second week, where we do a more precise determination of the melting point, you don't have to load up all the samples at once. I would suggest loading them up one at a time. So here I've prepared my sample number 1, unknown 1, and you put it in any one of the 3 slots. Okay? And you should go about all the same things. Make sure you can have a good view. Make sure you can see the crystals clearly. And then we want to go into the settings here. We want to make some changes. Right? Press mode once, and we'll see the plateau value. And if you do a precise heating, what you want to do is you want to set the plateau at about 20 degrees below the temperature that you observed it melting in your approximate determination. So in other words, this sample that I'm working with, I saw melt at 50 degrees when I was heating it very quickly last week. So for this sample, I want to set the plateau at 30. So I'm going to hold this button down until I get all the way down to 30 degrees. And what's going to happen in this precise determination is the device is going to heat up to the plateau temperature, and then it will heat at a slow rate above that temperature. That really is the meaning of the plateau, right? It is meant as the temperature that it speedily heats up to before it gradiates up at a more reasonable rate. So my sample melted at 50, so that means I'm going to set the plateau at about 30. Oh, okay. And for the heating rate, the slope, we want to set it at about 1 degree per minute. So it's at 5 now, so I'm going to go down. Up, 1 degree. And to save both of those things and exit, we just press mode again. Okay. Now, when I press the start button, the sample is going to heat up, and when it gets to 30 degrees, you're going to hear a beeping. Okay. Now, as it gets close to 30 degrees, you'll hear a few beeps, and then it'll indicate on the screen that it's at steady. Steady means it reached the plateau, and it's going to maintain as close as it can a constant temperature to the temperature you put in. So we put in 30, and it's around 29.7. We may see it fluctuate between 29 point something and 30 point something, but it's going to be at a plateau. That's an approximately constant temperature. To measure the melting point now, what we want to do is press the start button after you hear those beeps. And when you do that, you'll see the screen says that it's ramping. Now ramping means that it's heating at that rate that we set in as the slope before. So we want to watch the sample carefully while it ramps and look for all the signs that it's melting. When we see a melting happening at a slower rate like this, instead of seeing a single temperature, it's very common that we'll see a range of temperatures, and that's the way melting points are often reported. You may see a temperature where the sample initially looks like it's starting to, sometimes we say, sweat, like it looks a little damp, but it hasn't fully melted, and then you keep watching it, and you'll see it fully melt. Right? While it's in the ramping mode, there is a way to very precisely store the melting point that you observe, and it's to use these store sample buttons. Right? So after you heat for several minutes, let's say you see that the sample starts to melt, you see it starting to sweat, what you can do is press the store sample button. And then you will continue to see heating occur, because we're not done with the melting point. And when you see it completely melt, you can press store sample a second time. And that doesn't require then that you watch the screen precisely. That way you can keep your eye on the sample and not have to look down constantly. You can get a very precise determination of the melting point that way. Okay. Now, after you notice the sample melt and you've pressed one or possibly two of these buttons, in order to get those temperatures out, in order to read them, what you want to do is stop the heating process. Okay. And then if you press the buttons, you'll see the values that displayed that are what the temperatures were when you press that button. So The first stored temperature was 30.6. The second one was 30.7.